Very good morning, friends. Myself, Professor M.H. Annaya, and in today's video, we are going to work out a problem on the development of the lateral surface of a right circular cone. When I say a right circular cone, I mean that the base of the cone, that is a circular base, is perpendicular to the axis. Unless otherwise specified, whenever a cone is mentioned, it's always a right circular cone, wherein the axis is perpendicular to the base of this. Friends, in today's question, they have given a figure like this, wherein this portion is removed. This part shown here is removed, and we are interested to find out the development of this portion shown by color line. Friends, here this circle is not given, so let us draw the top view of this, and since this is a radius, very obviously this is going to be a diameter. If radius is 30, the diameter of the circle will be 60. So I am going to start with the drawing of the top view of the cone, that is a circle, and we will divide that into 8 equal parts by writing lines perpendiculars like this. Friends, we will name these as A, B, C, D, E, F, G and H. And here in the front view, friends, we will transfer all these points to the front view. This is A dash. B and H will fall on the same line. So I am going to join them by a thin line, and I call this as B dash comma H dash. C and G will come together, C dash, G dash. And here you have got the point E dash. So if you project these two, F and D will fall on the same line. So I am going to write a thin line through that. So I have drawn the circle representing the top view of the cone. I have divided that into 8 equal parts, and they have transferred all these points from the top view to the front view, and I have got the points and shown all the generators. There are 8 generators: O dash, A dash, O dash, B dash, etc. up to O dash, H dash. Now friends, to obtain the development of the part P shown in figure, you will have to draw the development of the cone, assuming it is not cut by any section plane or like this. So we will assume it is not cut by any section plane. Let us calculate theta, the angle subtended by the arc or the sector at the center O dash, that is the apex O dash. And this is given by the formula small r by capital R into 360 degrees. Friends, this R stands for the radius of the base. Diameter is 60, radius is 30 mm. And friends, this capital R is the length of the slant generator or the end generator. It could be O dash E dash or it could be O dash A dash. Since the top view OE is parallel to VP, this will represent the true length. I will call it as R. Similarly, this is also R. So I will show here this as R. So R can be obtained only after completion of this triangle to the given data. So friends, I am going to mark this sector with this theta. So this is we have got, you will be able to obtain this theta. Say you have got a value. It could be 130, 140, 150. It all depends on the dimensions of the cone. And theta I have marked here. Now friends, I am going to draw two lines of length is equal to R and R. Remember this R, I have shown it bigger in size so as to show the important points on the curve. So this R is equal to this R, is also same as this, and I have divided the circle into 8 equal parts. So also this sector is to be divided into 8 equal parts. Friends, we will just divide this sector into 8 equal parts. Now divide into 4 equal parts. Once again, in between these two, we write some more lines exactly in the center and obtain the number of division, that is 8. So friends, this is how we have divided this sector having angle theta into 8 equal parts. And friends, let us start numbering these as capital A, B, C, D, E, F, G, H and A, because the starting line and the end line, they should have the same marking. If you are starting from OB, it should end with OB and so on. Friends, now let us move on to this print view and see which are all the generators this arc or this portion is cutting. Friends, if you observe the figure, this is starting from point C and G on the base. So this is G and this is C. We will mark C and G. So this is a point on C, a point on G. We have got this point. Then, friends, if you see this generator, which is O dash, D dash, and O dash, F dash, these two are cut by the arc at this point, but these are not the true length generators. So I am going to shift that to the end generator O dash, E dash, which is the true length. So I will take this measurement from O on this OE and also OD and OF. Okay, this measurement I am going to mark on OD and OF. So friends, you got here. So I will mark the distance here OD and same distance on OF. OF and OD. So these are the 2 points you have got. So these two will be at the same distance. These are same. Friends, finally, it is being cut here. That is, this curve is cutting this generator O dash E dash at this point. And since this is a true length, I am going to transfer the distance directly onto the generator O dash E dash. It will come little up. So friends, we have got 1, 2, 3, 4. 4 points are there because this point gets repeated. And here, remember friends, for all the cones and the cylinders, whatever the point you get, whether it is cut by a section plane like this, or a vertical section plane, horizontal section plane, whatever it may be, the points, whatever you get there, are to be joined by a smooth continuous curve. So friends, I am going to join all these here by a smooth curve. This is how the curve is going to appear in the development. So friends, I have joined this. Now friends, if you want, you can just mark them also. You can say point C and D as 1. This is 2. 3 is the highest point. 4 and this is again 1. So 1 is on C and G. This point is 1. Then on OD, OF. OD and OF, you have got points 2, 4. This point is 2, 4. And the last one, the highest point is 3 on the generator O dash E dash. Friends, you remember this part, the portion below this is removed. So this portion won't exist. And the remaining border of this figure is to be shown by dark line. So this is one line. And here, friends, this is retained, you have to show. This portion is also retained. And this OA, you can just see the figure. OA is completely retained. OB and OH are also retained. OB, OH retained. And then you have got OA completely retained. and this OC and OG are also there. So OG completed is there and this is also there, and this portion is removed. This I have to show by very thin line just visible to you. And friends, this will give you this figure OA, and this part will give you the development of P, the lateral surface of this cone which is cut by an arc like this. Friends, I hope the presentation was interesting. Please go through the complete video without fail. And if you like this video, please don't forget to share with all your friends. Have a wonderful day and thank you very much.